Unit 5.6 is looking at linear inequalities. Remember, inequalities are greater than, less than, greater than or equal to, less than or equal to, right? And we learned to graph those on a number line, open circles and closed circles and arrows in one direction or the other, right? So, linear inequalities, right? We're looking at systems of linear inequalities. So what's the correct possible solution set if two lines cross and you know that this is possible and this is possible, then this becomes possible, right? So how do you put that into words? How do you put that into words? Similar to a linear equation, but uses an inequality symbol. But uses an inequality symbol. Right? So, for example, greater than, less than, greater than or equal to, less than or equal to. Right? Inequalities. Meaning not 100% equal. It might be equal, but it might not be equal. Right? Solution for all of the ordered pairs that make the inequality true. All of the ordered pairs that make the inequality true. All right. So, they're going to give you an example. Right? It says, determine which ordered pairs determine which ordered pairs are solutions to the linear inequality below. Alright, so this is your x, this is your y. Substitute the value in and see if it's true. So 2x minus 3y is less than 15. True or false? Let's find out. 4 minus 15 is less than 15. Negative 11 is less than 15. True. This ordered pair makes this statement true. Again, xy. 2 times negative 1 minus 3 times negative 7 less than 15. Negative 2 plus 21 is less than 15. 19 is less than 15. No, it is not. That's false. That ordered pair does not make that equation true. Right? We'll check the other two. How do I make that stop? Okay. xy. 2 times 3 minus 3 times negative 4 is less than 15. 6 plus 12 is less than 15. 18 is less than 15. False. 0, 0. 2 times 0 minus 3 times 0 is less than 15. 0 minus 0 is less than 15. 0 is less than 15. True. So we're just looking for the ordered pairs that make the equation true. Okay? Alright, in order to do this, you can graph them. That is one solution. Just like with linear equations, your system of linear equations, graph them to find the solution. One way to do linear inequalities is to graph them to find the solution possibilities, right? So, it says, put the inequality in slope-intercept form. Good news, it's 98% the same as doing it with linear equations. There's only one little difference. Be sure to flip the inequality symbol if you multiply or divide by a negative number. That's your one little difference. If you multiply or divide by a negative, you're going to flip the inequality symbol. So if it starts like this, it's going to end like this. Only if you multiply or divide by a negative number. Alright, then we're going to graph the line. Alright, we're going to use a solid line. Right, for greater than or equal or less than or equal. So if it includes equal, then it has to be a solid line because it includes everything on the solid line. Right? And you're going to use a dashed line. Right, so solid line for greater than or equal and dashed line for greater than or less than, because that means it doesn't include the values on the line. All right, you're going to shade above. You're going to shade above the line for greater than or equal. So if you have a line, it's greater than or equal, you're going to shade above the line. And you're going to shade below the line for less than or equal. So if you have a line and it's less than or equal, you're going to shade below the line. With me so far? All right. For example, I love examples. All right, so first thing you have to do is look at it. Is it in slope-intercept form? No. Put it in slope-intercept form, right? So we need to isolate the y, so we're going to subtract 2x. It's going to leave you with negative 3y is less than negative 2x plus 15. Remember, if you multiply or divide by a negative, you're going to flip the symbol. Greater than. It's going to become greater than 2 over 3 x minus 5. Now it's in slope-intercept form. It doesn't have an equal sign underneath it, so I need a dashed line. My first point is going to go at negative 5. 1, 2, 3, 4, 5. My second point is 2 up, 3 right. 2 is all that's going to fit on this graph, and that's okay. But remember, it's not equal to, so it needs to be a dashed line. Dashed line. I know, that's not even close to true. Don't judge me. Right? And because it's greater than, shade in above the line. Above. All of this is possible answers for that. All of this makes that equation true. Nothing on the line makes the equation true, and nothing below the line makes the equation true. But everything above the line makes the equation true. Okay, we'll do some more. It's all right, we can do that. Graph the linear inequality to show all possible solutions. All right, so first we have to make sure it's in slope-intercept form, and if it's not, we need to put it in slope-intercept form. This one is in slope-intercept form. Boom. This is your B. This is your M. First point, next point. -5, -1, -2, -3, -4, -5 on the y-axis. Next point, up 1, right 3. Up 1, right 3. Up 1, right 3. Up 1, right 3. Down 1, left 3. Down 1, left 3. Down 1, left 3. Don't judge me. I needed to put all the lines. I needed to put all the points. It makes me happy. Alright, greater than, but not equal to. So we're going to do a dashed line. Which means it does not include the ordered pairs on the line. But it is greater than, so it includes everything above the line. All of these are possible answers. That's all you have to do. That's it. Alright, same thing. This one is not in slope-intercept form. So we're going to move the x term to this side. Right? In order to do that, we're going to cancel it over here and move it over here. That's going to leave you with -2y is greater than -5x plus 12. We're dividing by a negative, so we're going to flip our symbol. Y is less than 5 over 2x minus 6. Alright, y is less than 5 over 2x minus 6. This is my y, this is my x, this is my origin, that's my 0. We're going to go down 6. 1, 2, 3, 4, 5, 6. And then directions. 5 over 2. 5 up, 2 right. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 2. I won't do them all this time. That does not look lined up. Double count your points. 1, 2, 3, 4, 5, 2. Oh, that's better. If you did it right, they should line up. Alright, and now let's look. It's going to be a dashed line, and we're going to shade below the line because it's less than. So, dashed line. Oh, that's rough. Let's do this way. Dashed line, and we're going to shade below the line. Alright, once you've got it, move on ahead and then use my video as a way to check your work. Alright, solve for y. Ooh, I put equals out of habit. I don't know if you can see the green. I don't like using the green. I think the red's the most visible. And then divide by -1. If we're dividing or multiplying by a negative, you're going to flip the symbol. And it's x minus 8. So our b is -8. And our m is 1 over 1. So -8. 1, 2, 3, 4, 5, 6, 7, 8. And 1 over 1. Okay, I'll stop. And it's greater than or equal to, which means you're going to do a solid line. Oh well. And it changed to less than or equal. Be careful, double check your answer, which I would have got it wrong. It's still a solid line, but it's going to be less than, so we're going to shade below the line. Hopefully you're pausing the video and doing it ahead of me. If not, when you go back and do the evens, make sure you go on quizzes and do your self-check. Don't come take the mastery check until you're 100%. It just makes more work for you and for me. Alright, x is less than or equal to -4. Alright, so we know how to graph this. Right, on the y-axis, we put a point at -4. Right? And then we draw a line. Because the point's on the y-axis, the line is horizontal. It's parallel to the x-axis. Right? And it says less than or equal, so we do a solid line. And less than means you're going to go below the line. Good? All right.